Okay, so today we're on unit 10.4. Okay, so for 10.4, we're going to talk about the probability of multiple events. Okay, so today we're going to work on basically what's the probability that not just one thing is going to happen, but more than one thing will happen. Okay, so we have a couple of definitions that you basically need to know. Okay, the first one is something called a disjoint event. Okay, disjoint. Okay, a disjoint event is also called mutually exclusive. Disjoint or mutually exclusive. Gentlemen, please. Okay. So disjoint, joint would be they have something in common. Disjoint is basically events that have no common outcomes. Events that have no common outcomes. So two different things happening that it's not possible that both could happen. Okay? So something like if I picked one person in this class and it was either a sophomore or a junior. It's not possible that I could pick one person and they would be both a sophomore and a junior. Right? You are classified as one. So disjoint events are events that have no common outcomes. Not even possible. So there's a couple of definitions you need to know, or formulas that you need to know. And the first one is that the probability of A and B happening, okay, and this is when things are not related, okay? Probability of A and B happening is the probability of A multiplied by the probability of B. So something like picking a sophomore. So if I pick two people, picking a sophomore and then a junior. Okay, so picking a sophomore and then a junior. So you would find the probability of picking a sophomore and multiply it by the probability of picking a junior. Okay, so that's just one type of example. Okay, you also need to know that the probability of A or B happening is equal to the probability of A plus the probability of B. So you are going to have to memorize that formula, okay? And coincides with multiply or coincides with addition. Okay, that's just something that you have to memorize. Okay, so for example number 1, find the probability of A or B given that the probability of A is equal to 0.2 and the probability of B is equal to 0.3. Keep in mind that whenever you see the word probability, your answer has to be a fraction or a decimal, okay? It cannot be over 1. Probability is talking about a percentage, okay? So it's always talking about either a fraction answer or a decimal answer. And whatever kind of problem you start with, so like these are in decimals, that's where your answer should be ending up. Okay, so this is the decimal to start with, so you're going to end up in decimals. So we want to find the probability of A or B, so we're just going to plug into that formula. Probability of A or B, what do I have to do? Am I going to add these together or multiply them? Add them. So it's equal to 0.2 plus 0.3, and that equals 0.5. If you put the 0 in front, that's fine. I'm not going to absolutely require it, though. That's your answer. Okay, so just make sure you're using the right formula based on what the question is asking you. Can you write this down, please?
I am writing it down. I never write this down.
Okay, well, I need you to.
I am.
You need to. Thank you. Okay, same thing for number 2. Okay, number 2, I'd like you to find the probability of A or B given that the probability of A is equal to 1/3 and the probability of B is equal to 1/2. So find the probability of A or B. What? Oh. So to work this out, what are we going to do here? Am I going to add or multiply? Add. Okay, so you're going to add the probability of A, which is 1/3, plus the probability of B, which is 1/2. Can you add these together the way they're written? No. Okay, you have to change them to be a common denominator. What's the common denominator between 3 and 2? 6. Okay, so rewrite these. Okay, 1/3 is equivalent to how many over 6? 2/6. Plus 1/2 is equivalent to how many over 6? 3. You add those together, you should get 5 out of 6 for your answer. I thought you said 1. Sorry, I missed the top. So 5/6 is your answer. So these are called disjoint events, okay? So not joined, okay? Mutually exclusive. The next thing we're going to talk about is something called non-disjoint events. I honestly do not know why they're not just called joint events, because this is basically a double negative, non-disjoint events, okay? And that basically means that they are overlapping. Overlapping events, or could have an outcome in common. Okay, they could have an outcome in common. So this is basically like trying to find, in this class, picking out someone that is a sophomore and a girl, okay? You'd have to add up all the sophomores and then add up all the girls. But some people I might have counted twice. I counted them as a sophomore and I counted them as a girl. So you have to subtract out. So that's why these are called overlapping, because one person could be both. Okay, so the probabilities for this is probability of A or B is equal to the probability of A plus the probability of B minus the probability of being both A and B. Okay, so there's some overlap. There's some people that would be both. Okay, so that's like asking what's the probability of picking one girl or one person in this class, like one person's name off the roll sheet and it was either a girl or a sophomore. Okay, you'd have to add up all the girls and all the sophomores and then subtract people that are sophomore girls. Okay, because I double counted them. This is usually a little bit easier to deal with when we have like actual facts instead of just random numbers. Okay, but when it's actually, it gives you more of like a word problem. All right. So for this one, for example number 3, again, I'd like you to find the indicated probability. If you're given that probability of A is equal to 0.4, probability of B is equal to 0.25, and the probability of both, being both A and B, is equal to 0.15. I'd like you to find the probability of picking one or the other. So if I pick just one, how do I find the probability of it being one or the other if I'm just picking one person? So this is like find the probability of picking a girl or picking a sophomore. So what you'd have to do is you have to plug in probability of picking a girl, which we said probability of A was 0.4. Add to that the probability of B, so probability of picking a sophomore, and we said that was 0.25, but subtract out the people that I double counted. Okay, I double counted how many people? Probability of A or B was 0.15. Okay, double counted them. Then if you work this out, you should get what? 0.4 plus 0.25 gives you what? 0.65 minus 0.15 equals what? Line up the decimals. 0.5. Okay, you guys should be able to just add those together. Okay, so just 0.5. Question, Sam? Four tenths plus 0.25. We line up the decimals. 0.4, 0.25. You have to line up the decimal place. 0.4 is the same thing as 0.40. And then line them up. Want to do the same thing when you... So whenever we're working with decimals, you have to line up the decimal places. Okay, question on how I did that. Is this easy? Is this difficult? This is apparently boring. Obviously, sorry. Okay, now, also working with non-disjoint events, okay, so overlapping events. For number 4, if I give you that the probability of A is equal to 0.25, probability of B is equal to 0.35, probability of A or B is equal to 0.4, and I want you to find probability of A and B. Try that one. Using that exact same formula I just showed you. So what's the formula that I'm plugging into? Probability of A plus probability of B minus the overlap, so probability of being both A and B, is equal to probability of A or B. So I would always write out that formula and then copy things in underneath. So probability of A is 0.25 plus probability of B is 0.35 minus probability of A and B. Do I know that yet? That's what we're solving for, so I'm going to put in an X. Equals A or B is 0.4. So you're not always just plugging in on the left side, and that's okay. Okay, you can do that. What's 0.25 plus 0.35? 0.6. Okay, if you write 60, that's fine. So 0.6 minus X equals 0.4. Then what would you do? Subtract. So subtract 0.6 from both sides. We subtract, we get negative X equals negative 0.2. Got rid of the negative, divided away. So X is equal to 0.2. So the probability of being either one is equal to 0.2. That's your answer. So you're just plugging into that formula, make sure that you're plugging in the right spot. Okay, the next thing we're going to go over is something called complementary events. Complementary events. Okay, and basically that is events that are opposites. Events that are opposites. So things that are opposite of each other. So an example of that would be something like rain or no rain. Okay, so the probability of rain or the probability of not raining. It's either raining or it's not. Okay, there's not any other things, okay? Being true or being false, or, well, we'll just leave it at that. Okay, or being true or false. Okay, you need to know that these always add up to equal what? What do you think they always add up to equal? 1, okay? The probability of rain and the probability of no rain is always equal to 1 or 100%. Okay, so the way we write this is we're going to ask you to find the probability of A naught, okay? And the way we write A naught is just with a line over the A. Okay, so the probability of A not happening. If I tell you that, for example, number 5, I tell you the probability of A happening is equal to 0.4. What is the probability of A not happening? So like the probability that it's going to rain today is 40%, or 0.4. What's the probability that it won't rain? 60%, or 0.6. Okay, and you want to leave your answers, however your answers start, you want to leave them that way. Okay, so if it starts in decimals, starts in percent, starts in fractions, you want to leave them in that same answer, same format. Okay, try another one. The probability of A is 2/3, and the probability of A naught is what? So the probability of passing this next test is 2/3. What's the probability of not passing it? 1/3. Okay, it's just, these are called complementary, so they add together to equal 100%. That's it. Okay, anyone have questions on how I did that? Okay, we're going to do a little bit more. We're going to talk a little bit about the marbles again. Okay, so let's look at marbles. You did some marbles yesterday. Okay, for example, God, where are we on? Example number 6. If I tell you that a bag contains 7, sorry, thank you. A bag contains 6 white, 3 blue, 7 green marbles. Yesterday, what you were dealing with was just picking one. Today, we're going to do multiple events, so you're picking more than one. Okay, so a bag contains 6 white, 3 blue, and 7 green marbles. If 2 marbles are drawn from the bag or chosen at random. Okay, 2 marbles are chosen at random. Find the probability that they are both white. What's the probability that they are both white? So are these independent or dependent events? Does what you pick on the first time have anything to do with what you pick out the second marble to be? Does it? What's the formula for picking both white? Is that an and or an or? Probably picking white. And then is it or another white or and another white? And. So that's a multiply. Probability of picking another white. So what's the probability that the first one you pick is white? How many total whites are there? 6. Out of how many total marbles are there? 16. Add these together, it's 16. Use calculator if you need to. Multiplied by, what's the probability that the next one's white? If I picked one marble out that was white, how many are left that are white? 5. Out of how many total are left? 15. Okay, if I took a marble out of the bag, it doesn't say I put it back. So if you're taking out 2, you're assuming that you didn't put back the first one. Then I would cross-reduce first. Okay, you don't have to, but I would try to cross-reduce first. So 6 over 16 reduces to 3 over 8. Okay, multiplied by 5 over 15 reduces to 1/3. Then you can cross-reduce here if you want to, or you could multiply and reduce at the end. These 3's are going to cancel each other out to be 1s and 1. Then multiply across the top. 1 times 1 is 1 over, multiply across the bottom, 1 and 8. So the probability of picking 2 marbles and having both of them be white is 1 in 8. That's your answer. And remember, anytime you see the word probability or that P, you have to have a fraction or a decimal answer. Okay? What's the probability that you pick both that are green? What's the probability that they're both green? So that's the probability that the first one's green. Is it multiplied by the second one being green or added? Multiplied because they're both being green, so that's an and probability. So what's the probability that the first one is green? How many greens were there? 7 out of how many total? 16 multiplied by how many greens would be left? 6 over 15. Okay, and you can cross-reduce here if you want to, or you can reduce in the next spot. Doesn't really matter. So what could reduce here? 6 and 16 could reduce. 2 goes into both of those. So you would get, what, 3 over 8? Can anything else reduce? The 3 and the 15 could reduce, or you could just multiply across and reduce later. Does not matter at all, okay? 7 times 3 gives you 21. Over 8 times 15. What's 8 times 15? You guys can do this. 120. Okay, what goes into both 21 and 120? 3. So 21 divided by 3 gives you 7 over 120 divided by 3 is 40. That can't reduce anymore, so the probability of picking 2 green marbles is 7 out of 40. Questions on how I did that? Okay, 2 more for you. Okay, I know these were kind of long today. What do we got? Number 8. Okay, now we're going to move on to cards. Okay, so deck of cards. When we say a standard deck of cards, that just means the ones that are listed on the board. Okay, so no jokers are in there. Okay, so standard deck of cards means no jokers. So if you know that a card is drawn at random from an ordinary deck. Card is drawn at random from an ordinary deck, okay? What's the probability that it is a jack or a 6 of clubs? What's the probability that it is a jack or a 6 of clubs? So automatically you see the word or, what does that mean you're going to do? Add together. So you want to find the probability of it being a jack plus the probability of it being 6 of clubs and subtract the probability of being both. Okay, so you're going to subtract the probability of it being both. Because when you're dealing with cards, there is possibility that it could be both. Okay, so what's the probability of picking a jack? How many jacks are there in a deck of cards? 4 out of a total of 52. Plus, how many 6 of clubs are there? 1 out of 52. How many are both a jack and a 6 of clubs? Is it possible to have a jack 6 of clubs? No, so this is just minus 0 out of 52. Okay, there is no overlap there. But I want you to get used to always subtracting the overlap just in case there is. So when you add these together, 4 plus 1 is 5, minus 0 is still 5 out of 52. That can't be reduced, so that's your answer. Okay, that's your answer. Okay, same thing here. This will actually be our last example. We're going to keep going. A card is drawn at random from an ordinary deck. Okay, now I'd like to find the probability that it is... Sorry, I lost my place for a second there. What's the probability that is a queen or a heart? Queen or a heart? That's a heart, even though it doesn't really look that good. I should have written that probably. So what's probably that it's a queen or a heart? So you're going to have to find the probability of being a queen plus the probability of being a heart minus the probability that it's an overlap or that it's both. So how many queens are there? What's the probability of picking one card out of a deck and it's a queen? 4 out of 52. Plus, what's the probability of picking a heart? How many hearts are there? 13 out of 52. Okay, there's 13 of each suit. Minus, what's the probability of both? How many queen of hearts are there? 1. Okay, there's a queen of hearts. So you can't pick, if you pick all the queens, And then the hearts, right? You've double counted the queen of hearts. So minus 1 over 52. So if you work this out, 4 plus 13 is 17. Minus 1 gives you 16 over 52. And what does that reduce to be? 4 out of 13. That's the answer that we're looking for.
We're done.
Okay, nope. Now find the probability of picking a queen and a heart. What's the probability of picking a queen and being a heart? That's a heart. So what's the probability of something being a queen and a heart? How would you figure that out? I'm going to show you there's 2 different ways you could do this. Okay? First is finding the probability of picking a queen, multiplied, since this is an and, probability of picking a heart. How many queens are there? 4 out of 52. How many hearts are there? 13 out of 52. If you multiply these together, this reduces to 1 over 13. This reduces to 1 out of 4. Then if you multiply across the top, multiply across the bottom, you get 1 out of 52. So you can do it this way. This is kind of the long way. Or you can realize there's only one queen that's also a heart. So you can use the kind of common sense method. Okay? You don't really have to do math. You just have to think about it. There's only one queen that's also a heart. Okay? So you don't always have to do the math. A lot of probability and statistics is very common sense based. Okay? If you don't see that automatically, you can definitely use the math, and that's fine. Okay? You guys do have homework today. Homework is going to be on page 710. You are doing numbers 3 through 25. Okay, page 710, numbers 3 through 25. I will put that up for you. Okay, but you are also taking a quiz. Okay, so I put it up here so you can see it, but you are also taking a quiz. And you're going to finish the quiz first.